Okay, hi everyone. So last video was 6.5 minutes, getting better. That's what it's about, Basvik, not giving up, persevering. So we're now moving on to factorizing section 5. Factorizing, especially when it comes to quadratics, is always a bit tricky for people at first. I think the most important thing is once you factorize it, you need to expand your answer to check whether you're right or wrong. But this first section, factorizing using difference of two squares, this is our a squared minus b squared business, where a plus b, a minus b is the same as a squared take b squared. And if you multiply that out, this is exactly what I mean. So when you factorize, that means put it into brackets or take out a common factor, right? Then you should expand it again to check. So a times a is our a squared, a times minus b is minus ab, plus, so that's a dealt with, now we're dealing with b. So b times a is plus ab, and b times minus b is minus b squared, and the minus ab and the plus ab cancel, which is exactly the whole point of difference of two squares, because you get two terms. The hint's in the name, okay? Notice then that what's actually happened when we write a squared minus b squared is that the signs inside are different. And actually, the term on that left-hand side is the square root of the first term. You see? The square root of a squared is a. And on the right side, that's the square root of b squared, which is b on both sides. Okay? So the same can apply if I had a to the 4 take b to the 4. As long as you got that minus, you must have the minus there. So plus or minus, the square root of a to the 4 is a squared, because a squared times a squared is a to the 4. The square root of b to the 4 is b squared, okay? Likewise, if I had a take b, a bit of a hint here for the actual question in your booklet, but the square root of a is square root of a, square root of a, and square root of b is square root of b, square root of b. Can you see? You can use the difference of two squares to split up items when you've got two objects with a minus in between them. All right, so flip back so it goes to regular size. Right, so let's start dealing with this then, factorizing this. So I can see it's a difference of two squares because I've got two terms and I've got a minus there, so minus and a plus. Square root of the first term, 81, is 9, so that goes in both. Square root of 9x squared, so square root of 9 is 3, and square root of x squared is x. So there we go. And again, you can quickly multiply that out to check that it works. So 9 times 9 is 81, 9 times 3x is plus 27x, minus 3x times 9 is minus 27x, and minus 3x times 3x is plus 9x squared. Cancels, cancels, yes. We do have what we started with. Oh, sorry. Minus 3x times 3x is minus 9x squared. So yes, we do have what we started with. Okay, let's do the same with the second one. So 16, it has got a minus in there. So we're going plus minus. Square root of 16 is 4, both sides. Square root of 49 is 7. And the square root of x squared is x. There you go, done. Like our a take b here, we've got a similar situation. So there is a difference of two squares because there's a minus there, so plus or minus. Square root of 8 is square root of 2 from our surds work, square root of 4, so that's 2 root 2. The square root of x is the square root of x. So there we go. That's written as a difference of two squares. And now this x to the 4 take y to the 4. This is an interesting problem. So let's do that again. If we were to factorize this as far down as we can go. So it is a difference of two squares problem. So plus or minus, because there's a minus there. Square root of x to the 4 is x squared, and x squared, and y to the 4, y squared. But notice, I did bring up a to the 4 and minus b to the 4 earlier, but notice we could actually factorize this further. Because the x squared plus y squared, that is a two-term object, but it's got a plus there. So this is not a difference of two squares. However, this one has a minus, and can be split up, can't it? Because this is now in the form of a squared minus b squared. So plus or minus square root of x squared is x, square root of y squared is y. So actually that is the fully factorized expression using difference of two squares. Now, for exercise 5b, this time finding common factors and trying to factorize things, I've purposely made this one look a little bit nasty because the process is always the same, okay? What we're trying to look for is common things to each other. So let's start with the numbers. This has a 16, this one doesn't, but 8 is a multiple of 16. So we could take out 8, but we can't because actually 4 is not a multiple of 8. But 8 is a multiple of 4 and 16 is a multiple of 4. Do you see? So I could take out a factor of 4. So I'm looking for things which are common to each other. Okay? So if I took out a factor of 4 of 16, I'd get 4 because 4 times 4 is 16. Took out a factor of 4 of 8, I would get 2. Took out a factor of 4 from 4, I would get just 1. Okay, so I'll put 1 in there for now. Now let's deal with the next term. So we're going to deal with the x cubes now. So this has an x cubed, this one just has an x squared, and this one has an x cubed. So like with the 4, you're trying to find the smallest one that they all have in it. So they don't all have an x cubed, but they do all have an x squared. You see? So I could take out an x squared. So if I took out an x squared of this 16x cubed bit, we would need to times that by x, wouldn't we? Can you notice then, if we times the 4x squared by the 4x, we would get 16x cubed. That's good. So you see how I'm checking by multiplying out? Now we've got this, notice we had a minus here, so we're going to have a minus here as well. Okay, I've got an x squared, I've got an x squared, so again, that's like timesing it by 1, so I can just leave that. And here we've got an x cubed, here I've got an x squared, so I would need to times my 1. I'll just replace that by an x. And notice there's a plus here, so I will put a plus here. Okay, so it's starting to look good. Now we're going to go for the next term. So y squared, this has a y squared, this has a y squared, and this has a y squared. So they all have a y squared. Can you see? So up until these three things here, if I multiplied this out, I do have what I started with. So 4x squared y squared times 4x is 16x cubed y squared, and 4x squared y squared times minus 2 is minus 8x squared y squared, etc. So we've just got one term left, which is the z. So this has 1z, this has z squared, and this has 1z. So the smallest power is z. So the 4x won't change because z times 1 is still z, but the 2 though has a z squared. So z times z makes z squared, and the last bit is fine. Okay? Hopefully this is making sense on common factors, right? But now we've got something different. This idea of factorizing a quadratic, this is something you've been doing at GCSE for a long time, and you know, kind of sometimes it just does help to find out, you know, what we need to do. So we need to find two things that time together to make x squared. So that's got to be x and x, doesn't it? Right? We need to find two things which time together to make minus 4, but add together to make minus 3x. So obviously 4 can be split into 2 and 2, but 2 plus 2, or any combination of it, will never make 3, whereas 4 and 1, which are factors of 4, 4 take away 1 will make minus 3x. So I reckon there's a 4 and 1 in there, do you see? Now, where do we put the signs though? Well, it has to be minus 4 here, because if I multiply out to check at the moment, also I'm checking, yeah? So x times x is x squared. X times minus 4x gives gives me minus 4x. And this is a minus, so I need the bigger number, 4, to have the minus next to it. And I need a number here. This has to be a plus with the 1, because 1 times minus 4 gives me minus 4. Do you see? So two numbers that times together to make minus 4, but add together to make minus 3. So plus 1 times x, there's my plus x, and my minus 4 here. You see the fish? So it does work. Hooray! Smiley face. Next one then. Let's try factorizing something a little bit harder. So with this, it requires patience and often kind of where to start. Well, there are hints about where to start. Look for prime numbers. 3 is a prime number, which means it can only be split into 1 and 3. That's helpful. That's helpful. Now, again, what two numbers, because I've already got my two numbers that times together to make 3, right? But I need to make it minus 3. And now I need to think of what two numbers make 4x squared. Well, it's got to be x and x, right? It could be 4 and 1, or it could be 2 and 2. I don't know. I don't know. I'm going to try 2 and 2 and see what happens, okay? So if I multiply out, I get 2. So this is me checking. Remember, always multiply out to check. You should never get this wrong because you can always check it. So 2x times 2x, so 2 times 2 is 4. X times x, x squared. Okay. And at the moment, I need a minus 3 and I need a plus 4x. So can you see that? Again, we need the bigger number to have the bigger sign. Because if I put a plus here, I've got a plus here, and 3 times 2 is bigger than 2 times 1, obviously. So the bigger number has to have the plus. And this one has to be the minus, because minus 1 times 3 is minus 3. So I am using logic here, okay? So check that. So 2x times minus 1 and 3 times that. And we're all good. It works, okay? So I'm using logic. Part D. So don't despair about this quadratic stuff. You can do it. You just need to check. Check. It's okay to get it wrong. We all do. But what's not good is giving up, okay? So this D, this is a cubic, links with what we did earlier here for A. You're trying to find common factors to everything. So none of the numbers are common to each other. 3, 5, and 2 aren't multiples of each other. They're all prime. They do, however, all have x's. So we're looking for the smallest x power, aren't we? Because they're common to everything. So it looks like x is common to everything. So at the moment, if I was to times x by something to get 3x cubed, it would have to be 3x squared, wouldn't it? Next one, I've got 5x squared, so that needs to be 5x. And this one needs to be minus 2. Again, you can multiply it out to check. Now, now we're back to like what we were doing in C. And we're factorizing this section. Again, it looks horrible, looks like lots of options, but there's a prime number there, 3x squared. 3 is prime. So it's got to be 3x and x. Okay, 2 is prime here. So it's got to be 2 and 1. So it's either going to go 2 and 1 here, or it's going to go 1 and 2 here. So there's nothing to kind of worry about. You just keep trying the options until you get there, okay? So again, this is a plus, so I need the bigger multiple, 1 times x and 3x times 2. That's going to be the bigger one, so the bigger one has to have the plus, okay, to match that sign. If that was negative, then it would be the other way around. This would have to be negative, okay? And as that's so, this one has to be negative, because minus 1 times 2 is minus 2. And if you multiply that out, it works perfectly, and we're happy.